So picking up where it is that we left off yesterday, I already gave a brief introduction on the concept of a limit. Now all that's going to be going on in today's video is going to be practicing different strategies for evaluating limits, because there are going to be different types of limits that can be evaluated and manipulated in different kinds of ways. So what I'm going to be trying to do in this video is teach you each of the methods that can be used in order to manipulate those functions in order to evaluate the limits properly. Different functions are going to require different manipulations, and I hope to try to get that across in this video. So let's start off with where it is that we left off yesterday. We're going to evaluate the limit as x approaches 2 for x squared minus 2x over x squared minus x minus 2. Now both of these functions, both in the numerator and the denominator, can be factored, so what we're going to try to do, but before it is that we do that, what we want to do is plug in the value that we're trying to evaluate the function at, the limit at, in order to see if it actually gives us an indeterminate form, because very often teachers will try to trick you and they'll go and say, go and evaluate this limit, and at the end of the day it requires no manipulation whatsoever. They just wanted to see if you knew that you could plug a value into a function to evaluate its limits. Very often people will make that mistake on a test. They'll try manipulating a function that doesn't require any kind of manipulation, and because of that they're going to waste a lot of time and possibly lose marks. So we try plugging in 2 into this function. If we were to plug in 2 over here, we would get 2 squared, which is equal to 4, minus 2 times 2, which is equal to 4. So we have a 0 on the numerator. And we have a 2 squared, which is 4, minus 2, minus another 2, that is also 0. So this is of the indeterminate form, 0 over 0, so we can carry on with our manipulations. So the first thing that we want to do is we want to try to factor whenever it is that we can. Factoring functions is going to be like your best friend whenever it is that you're trying to evaluate limits. So first step, limit as x approaches 2. Here in the numerator we see that we can pull out a common x factor. So x times x minus 2, and then in the denominator we are going to factor this quadratic equation by looking for two values that give a product of -1 and a sum of -1 and a product of -2, which is going to be the sum of these two values over here, 1 and -2, and a sum of -1 over here. So if we were to try to find those two values, that would be x plus 1 and x minus 2. Now we have two distinct factors in the denominator, so we can cancel them out. We can cancel out this x minus 2 with the x minus 2 in the numerator, and all we're left over with is the limit as x approaches 2 for x over x plus 1. Now it's just a matter of simple limit evaluation. All you need to do is plug in 2. So here we're going to take f of 2, which is equal to 2 over 2 plus 1, which is equal to 2/3. So the limit as x approaches 2 for this function is 2/3. Moving on, we want to evaluate the limit as x approaches 0 for the square root of x plus 4 minus 2 over x. So before it is that we try any kind of manipulation, let's try plugging in 0 to see if we're going to be wasting our time by making any manipulations. If we were to plug 0 into this function, we would get 0 over here plus 4 is going to be all in the square root. 0 plus 4 is going to be the square root of 4, which is equal to 2. 2 minus 2 is equal to 0 in the numerator, and x in the denominator is just going to be 0. So this is of the indeterminate form. We have to start manipulating it. So what we're going to be doing for this function is we're going to multiply by the conjugate of the term that contains the square root. So we're going to take the limit as x approaches 0 for the square root of x plus 4 minus 2 over x multiplied by, and taking the conjugate is basically taking the term that contains the square root, as I had mentioned yesterday, taking the term that contains the square root and changing the sign. So if this was a minus, we would make this a plus right over here. If this was a plus, we would make this a minus. Square root of x plus 4 times 2. This is essentially multiplying by 1. We're not changing the value of the equation in any way whatsoever. We just want to change the form. So all we need to do here is multiply this out, limit as x approaches 0. And whenever it is that you're distributing this, all you really need to do is you need to multiply the first term in here by the first term in here, and the second term in here by the second term in here. There's no need to FOIL this out completely. It'll all work out. So we're going to have left in the numerator an x plus 4, and then we're going to have a minus 4. X plus 4 minus 4, these 4's cancel each other out, we're just left with x. And we're going to have an x factor over here multiplied by this whole thing over here, which is going to be x, square root of x plus 4 plus 2. We also have a common x factor that can be canceled out, so we're going to cancel those as well. So all we're going to be evaluating now is going to be the limit as x approaches 0 for everything in the numerator is gone, so we're going to have 1 over the square root of x plus 4 plus 2. Here all we need to do is we need to plug in 0 into this function to evaluate the limit. So f of 0 is equal to 1 over the square root of 0 plus 4. This is going to be the square root of 4, which is equal to 2, plus 2 is equal to 1 over 4. Limit as x approaches 0 for this function is 1/4. Next up, we got the limit as x approaches 5 for x squared minus 6x plus 5 over x minus 5. Now before it is that we try any manipulations, let's try plugging in 5 to see if this works out. If we were to plug in 5 in the numerator, we would get 5 squared, which is 25, minus 6x, which is going to come to 30, plus 5. So 25 minus 30 plus 5, all of that adds up to 0. So we have 0 in the numerator, and then 5 minus 5 in the denominator. 0 over 0, indeterminate form, we're good to go. We can start our manipulations. So we're going to take the limit as x approaches 5. For this quadratic function can be factored out. All we need to do is find two values that add up to the coefficient right over here, -6. So two values that add up to -6 and have a product of +5. So let's try -5 and +1, -5 and -1. Those work out. So we're going to have x minus 5 and x minus 1 in the numerator, and an x minus 5 in the denominator. Now we can cancel out both the numerator and the denominator. We have a common factor right over here. And all we need to do now is evaluate limit as x approaches 5 for x minus 1. Nothing special over here, no more manipulations required. It's just going to be f of 5, which is equal to 5 minus 1 equals 4. Limit as x approaches 5 for that function over there is 4. Let's evaluate the limit as x approaches 4 for x squared minus 4x over x squared minus 3x minus 4. So in the numerator we can factor out an x, but before we try that, let's try plugging in 4 to see if any manipulations are necessary. If we try plugging 4 into the numerator, we would get 4 squared, which is equal to 16, minus 4 times 4, which is also 16, 0 in the numerator, and then in the denominator we have 4 squared is 16, minus 3 times 4 is 12, minus 4. We have 0 in the denominator, indeterminate form. We carry on with our manipulations. Limit as x approaches 4, and in the numerator right over here we can pull an x out, so we're going to have an x factor come out of here, and x minus 4, and in the denominator we are looking for two values that add up to -3 and have a product of -4. So if we add up to -3 and product of -4, that would be x minus 4 and x plus 1. We can cancel out both x minus 4's over here, And all we're going to be left with is limit as x approaches 4 for x over x plus 1. Now we have no problems. We can plug it into the function just fine. So we're going to take f of 4, which is equal to 4 over 4 plus 1, which is equal to 4/5. 4/5 is the limit of our function. Moving on, we are going to take the limit as x approaches -3 for x squared minus 9 over 2x squared plus 7x plus 3. So before it is that we start trying any manipulations, let's try plugging in -3 to see if everything works out to an indeterminate form. Otherwise, we'd be wasting our time. If we tried plugging in -3 over here, we'd get -3 squared, which is equal to 9. 9 minus 9 does come to 0 in the numerator. And if we tried plugging in -3 over here, we would get 9 multiplied by 2 comes to 18, minus 21 plus 3, this also comes to 0. So we have an indeterminate form. This is going to require a little bit of manipulation. So first we're going to write this out as the limit as x approaches -3 for, and in the numerator we notice that we have a quadratic function which also happens to be a difference of squares. So this can be rewritten as a product of x minus 3 and x plus 3. Now the denominator is going to require a little bit of factoring by grouping. What we want to do is we want to take two numbers that are going to add up to 7 and create a product of 6. So we're going to take 2x squared plus 6x plus x plus 3, because these two values are going to add up to 7 and they do have a product of 6, 6 and 1. And we're going to group these together. So we're going to group these two together. We're going to rewrite this as the limit as x approaches -3 for x minus 3 multiplied by x plus 3 in the numerator. And here we can factor out a common 2x, and it's going to leave us with an x minus 3, an x plus 3. And here we don't need to factor anything out. We can just leave this as a 1, and this is going to leave us with another x plus 3. Now we're going to combine these two terms and these two terms in order to create the two terms that we're going to be leaving in the denominator. So limit as x approaches -3 for x minus 3 multiplied by x plus 3 over, combine these two terms over here, so it's going to be 2x plus 1 multiplied by x plus 3. We have a common x plus 3 in both the numerator and the denominator. These can be cancelled out. X plus 3, gone. And we're going to be left with the limit as x approaches -3 for x minus 3 in the numerator and a 2x plus 1 in the denominator. Now we shouldn't have any problems plugging in -3 into the function. We can plug it in, so it's going to be f of -3, which is going to come to -3 minus 3 is going to be -6. And then in the denominator, we're going to have -3 multiplied by 2 is -6. -6 plus 1 is going to be -5. So these two negatives cancel each other out. The limit as x approaches -3 for this function is 6 over 5. Moving on, we are going to be evaluating one of the nastier limits that we're going to be encountering today. We're going to evaluate the limit as x approaches 0 for 2 plus x all to the third power minus 8 over x. So before it is that we move on, let's try plugging in 0 into this function to see if it gives us an indeterminate form. If we were to plug in 0 over here, we would get 2 plus 0, this is equal to 2, all to the third power, that's going to give you 8. 8 minus 8 is equal to 0. So we have a 0 in the numerator, 0 in the denominator, good to go. We are going to start our manipulations now. So we take the limit as x approaches 0, and very often whenever it is that you see an issue like this, what you're going to be expected to do is you're going to have to distribute this cubic expression right over here so that you can eventually cancel it out with this constant over here, because we can't do any factoring right now as it is. So what we're going to have to do is distribute 2 plus x times 2 plus x times 2 plus x. Then subtract 8 from all that, all over x. I don't know the cubic distribution formula right off the top of my head, so we're going to have to distribute that by hand. This is going to come to, this is a 4. This is going to come to a 4 plus 4x plus x squared, and then multiply that by another 2 plus x minus 8 all over x. Keep distributing it. It's going to come to the limit as x approaches 0. This can be multiplied out, so it's going to come to 8 plus 4x plus 8x plus 4x squared plus 2x squared plus x to the third, and then all that minus 8. Now we can cancel out a couple of common terms and join the like terms together, so we can cancel out this 8 with this minus 8, and we can join these x terms right over here and these x squareds. So we're going to take the limit as x approaches 0 for these two joined together to make 12x, and these squared terms join to make 6x, and this term is left on its own, so it's going to be x to the third all over x. Now what we can do is we can factor an x out of the numerator, so we're going to take the limit as x approaches 0 for this function over here. We take the x out of the numerator, we're going to be left with 12 plus 6, this was supposed to be a squared, plus 6x plus x to the third. X to the third, we're going to be factoring out an x, so it's going to be left with an x squared. And we have an x in the denominator. These two x's cancel each other out. So all we're doing now is evaluating the limit as x approaches 0 for the remainder of the function, which is going to be 12 plus 6x plus x squared. These two terms are going to go straight to 0. All we're left with is 12. So the limit as x approaches 0 for this function is 12. So the next function that we're going to be evaluating the limit of is going to be take the limit as x approaches -2 for x plus 2 over x cubed plus 8. So what we're going to be doing in this one is we're going to have to do a little bit of cubic factoring, but before it is that we do that, let's try plugging in -2, see if everything works out, if we're going to need to work on it. So we plug in -2 over here, we're going to get -2 plus 2, that comes out to 0, and in the denominator, -2 to the third power is going to come to -8 plus 8, also comes to 0, indeterminate form, so we're going to have to do a little bit of manipulation. So for those of you that recall that cubic sums of cubes can be factored, and they're going to be factored like this. X to the third power plus a to the third power can be factored as, and it's going to be x plus a multiplied by x squared minus ax plus a squared. So what we're going to be doing in this function right over here is doing exactly that. We're going to take the limit as x approaches -2 for x plus 2, and this denominator can be rewritten as we're going to take this x term over here and the cube root of 8, which is going to be 2, so it's going to be x plus 2 multiplied by this quadratic term over here, which is going to come to x squared minus 2x plus 4. So we're going to have a quadratic left over in the denominator. We can cancel out the x plus 2 with the x plus 2 over here. We're going to be left with the limit as x approaches -2 for 1 over x squared minus 2x plus 4. So all we need to do now is we can plug in -2 into this function, evaluate. F of -2 is equal to 1 on the numerator. We're going to plug in -2 over here. This is going to come to 4 minus -4. So it's going to be 4 plus 4. It's going to come to 8. Plus another 4 is going to give us 1 over 12. So the limit as x approaches, what was it, 0, -2. Limit as x approaches -2 for this function is 1 over 12. Very often, whenever it is that you're evaluating limits, the teachers are always going to tell you, evaluate the limit as x approaches 0, x approaches 0. X approaches 0 is the favorite limit of teachers, because it always gives you indeterminate forms. So, let's see, what do we got over here? Next up, we are going to evaluate, I think we got 2 more. 2 more or 1 more? 3 more. 3 more, alright. So we got the limit as x approaches, and speak of the devil, limit as x approaches 0 for the square root of 1 plus x minus the square root of 1 minus x all over x. So just as we normally do, we plug in 0 to see if this is going to work out. If we were to plug in 0 into this function, we would get the square root of 1 plus 0 is equal to 1, minus 1 minus 0 is also going to come to 1, so we're going to have a 0 in the numerator and x in the denominator, 0 over 0. And just like before, what we're going to be doing in order to manipulate this function is we're going to multiply by the conjugate. So just as we did before, we're going to take the limit as x approaches 0 for square root of 1 plus x minus the square root of 1 minus x all over x multiplied by the conjugate of this expression over here, which is going to be exactly the same, 1 plus x, but instead of this minus sign, we're going to put a plus instead. 1 minus x and square root of 1 plus x plus 1 minus x. We can distribute all this. This is going to come to the limit as x approaches 0 for 1 plus x minus, I'm going to keep this in brackets over here, 1 minus x all over x multiplied this factor of 1 plus square root of 1 plus x plus the square root of 1 minus x. So here what we're going to be doing is we're going to be adding up these, so it's going to be 1 minus 1, these 1's cancel each other out, and we're going to have a positive x subtracting off a negative x, so that's going to come to 2x in the numerator. So we're going to take the limit as x approaches, oh my god, I forgot how to draw an arrow. Limit as x approaches 0 for 2x over x multiplied by the square root of 1 plus x plus the square root of 1 minus x. Now we can cancel out the x's in both the numerator and the denominator. We're going to be left with the limit as x approaches 0 for 2 over the square root of 1 plus x plus the square root of 1 minus x. Now we should have absolutely no problem plugging in 0 into this function. If we plugged in 0 over here, we would get 2 over the square root of 1 plus the square root of 1, which is also going to be 2 in the denominator, so it's going to come to 2 over 2, which equals 1. The limit as x approaches 0 for that nasty function is 1. Going to be finishing up soon. We got 2 more. This one looks terrifying. We're going to take the limit as x approaches 0, once again, for this entire thing over here. It's going to be 1 over x minus 1 over x squared plus x. So if we tried plugging 0 into this function, well, we'd already be dividing by 0. We don't want to divide by 0. So immediately this is going to require some kind of manipulation. So what we want to do right here is we want to take these two and put them under a common denominator. So we're going to multiply the numerator over here by x squared plus x, and the numerator over here. So what we're going to want to do for this function is we're going to have to multiply this out so that we get everything under one common denominator. So we're going to take the limit as x approaches 0. This is going to be distributed so that it's going to come to, this is going to go up here, so it's going to be x squared plus x all over x multiplied by x squared plus x, and this term is going to be distributed over here, so it's going to be minus x, and all we're going to have here is going to have the x's cancel each other out. There's an x that can also be canceled out in the numerator and the denominator. So the limit as x approaches 0 for all we have left in the numerator is an x, and in the denominator an x squared plus an x. Once again, we can factor another x out of the denominator. Limit as x approaches 0 for x over x times x plus 1. These x's cancel each other out, and all we're left with is the limit as x approaches 0 for 1 over x plus 1. This is going to come to f of 0, which is equal to 1 over 0 plus 1. That comes to 1 over 1. So our limit is 1. Two more and then we're finished off with introduction to limits. Then we're going to be moving on to things such as continuity. We're going to take the limit as x approaches -4 for the square root of x squared plus 9 minus 5 all over x plus 4. If we tried plugging in -4 into this function, we would get -4 squared, which is going to come to 16. 16 plus 9, 25. Square root of 25 is equal to 5. So we do have a 0 in the numerator and a -4 plus a 4, 0 in the denominator. This is going to require a little bit of manipulation. So, as we know, up until now, everything that's involved a square root in either the numerator or the denominator, we're going to be multiplying by the conjugate. So we take the limit as x approaches -4 for the square root of x squared plus 9 minus 5 over x plus 4 multiplied by the square root of x squared plus 9 plus 5 over the exact same thing. I'd like to remind you that this is just like multiplying by 1. We're not changing the value of the expression. So we're going to take the limit as x approaches -4, and this is going to be distributed like this. This is going to come to x squared plus 9, and then -5 multiplied by 5 is going to come to -25 over a common factor of x plus 4 multiplied by the square root of x squared plus 9 plus 5. All we're going to be left with over here is going to be the limit as x approaches -4. If we were to take 9 and subtract 25 from it, it's going to come to x squared minus 16. So x squared minus 16 over x plus 4 multiplied by the square root of x squared plus 9 plus 5. And from this we know that this is going to be a difference of squares. This can be factored even further. So we take the limit as x approaches -4 for x plus 4 and x minus 4. And in the denominator we have the same mess as before. This is going to be an x plus 4, and this is going to be a square root of x squared plus 9 plus 5. We have common factors over here that cancel each other out. We've got the limit as x approaches -4 for x minus 4 over the square root of x squared plus 9 plus 5. Now if we tried plugging negative 4 into this function, we shouldn't have any more issues. If we tried plugging it in, we would get negative 8 in the numerator. And if we plugged it in over here, we would get 16 plus 9 is going to be 25. Square root of 25 is going to be equal to 5. So 5 plus 5 comes to 10. So we're going to have negative 8 over 10. Can be simplified so that it's going to be negative 4 over 5. Limit as x approaches negative 4 for this function is negative 4 over 5. And we're going to wrap this up. We're going to finish... Oh, wait. Was that it? Yep, okay, that was it. And that's pretty much it for today. I'm going to catch you guys in the next video, which is going to be... I think it's going to be discussing continuity. I'm going to check. But see you guys in the next video. Thank you for watching, and have a nice day.